Guys, there is our developed board. You can see that it is the PCB layout we just designed, and this is the schematic we made on the EasyEDA. You can see that how much beautiful it looks. It have a built-in onboard LCD connection as well, LM016, and there we have the PCB layout, and there we have the 3D visualization. You can see it looks wonderful. Okay, there you can see that the board is looking like, see, so you can see the tags as well. So learning microcontrollers, and this is a PIC16F877A development board. So guys, this is how you do it, just a schematic and then the PCB layout and then the 3D visualizer. Guys, welcome to learning microcontrollers. In this video we will make your PIC16F877A trainer kit schematic and a PCB design using EasyEDA Pro. So we will be using EasyEDA Pro to make a trainer board like you see in my videos. So this video we will be designing it, and then you can get it manufactured or you can manufacture it yourself as well. So let's get started. Let's open the EasyEDA Pro, this one. Not the standard version. To make a PCB layout and professional schematic, you have to open the EasyEDA Pro version. Just open it. It's opened. Now let me zoom in. Now on the window you can see that I'm using the half offline mode. Use the same, because if you don't use the half offline mode, then you will not have access to the SCS library. That is free. This software is completely free. I have a video on this, how to download and install it and use it. It's totally free, so you can go through that lecture to understand. So click on this new project. Write the name of the project, PIC16F877A development board kit, PCB layout, and sorry, I pressed some button, and schematic. That is the name I wrote. You may write any name. Click on save. Okay, once you click on save, this window pops up. Remember, you must be connected to the internet because we are using half offline mode. So we will need the libraries, because these libraries have every component. Now on the toolbar you see this IC. This is a component. Click on it. This window pops up. Now click on the LCSC library, and here you write the name of the component. I write PIC16F877A and press enter, and I wait. Okay, there we go, the PIC microcontroller, the assembly. This is the one we use. That's a DIP. Place it wherever you prefer, like this. Here we go, the PIC16F877A. Now we need the connectors, because like in case of an Arduino, we need a connector to connect the pins, so we can just connect the jumper wires on our development kit. So for that we will need a header, SIP header. So I go to the components again, and now to narrow in the search, I write header here, header, and it narrows in the connector. Then you have female headers. Click on it. And now here you can further narrow in. We need a single inline SIP. So SIP 20, yes, that's perfect. So apply filters. So there we go, SIP 20 header. Now to verify this, is it correct or not, you may click on the data sheet. It will lead you to the browser, and on the browser you can see the data sheet as well, which will show you additional information whichever is required. Like this, you can see that if it seems to be fine, then you may use it, else you may look for some other. Take a look here. It have all the required data sheet and other stuff. See, this is the data sheet. Here it shows the pitch to be 2.54. That is what we just want. So this is fine. I will use it. So now click on place. So PIC16F877A has 20 pins on the left and 20 on the right. So this will be the left side, and this is the right side. Now to connect them, you may connect pin number 1 to 1 by simply using the wire. You may use a wire if you want, like this. You may connect it, but I will do is that I will use a professional way. We will be using the nets. Now this is the in net on the floating tool. So just connect 1 to 1. Now then net 1 means this is the pin number 1. Pin number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we missed a pin. 1, 2, 3, 4, 5, 6, 7, 8. There should be 9. So I make it 9. 9. Then we have 10, 11, 12, 13, 14, 15. If you make the wires, then that will takes a lot of time. So this is better, and this makes your schematic look way better, and you will also see more advantages as well in the future. Okay, still I think we made a mistake somewhere. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is here. So this is 13 and this is 14. I'm just naming the nets to be the same as the pin number. So 1 for 1, 2 for 2, 3 for 3 to make our life easier. So this is 15. Then we have 16. So for the left side we have 20 pins. So one connector for the 20 pin. 17. Then we have 18, 19, and finally 20, like this. Now on the right side, do the same in net. This is the in net connected to the right side as well. Now this pin is the 21, so I just invert this, like I make it Y flip or X flip, Y flip, this one. Now see pin number 1, that is a 21, 2, 3, 4 and up to 40. It's a DIP 40 package. So this is the N pin. So this will be the 21. So I make it 21. Then we have 22. 22, 23, 24, 25, 7, 8. This is 23. This is 24. This is 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Okay. Okay. 21, 2, 3, 4, 5, 6, 7, 8. This is 29. This is 30. This is 31. This is 32. This is 33. This is 34, 35, 36. Okay, few pins left. 37, 38, 39 and pin number 40. So 37, 38, 39 and 40. That's perfect. Now we connect it to the microcontroller. Now take the out net. This is the out net. Now connect them. Press spacebar to rotate it. So this is our pin number 1. Then just connect them and give them the same net. This will automatically connect the pins. So 11, 32 connected to all of them. Then we rename them. 19, 20, 22, 27, whatever they are. Just connect them first. Then we will simply rename them. Like this. Now give them the name as per the pin. So this name 1 means this is net 1. So see now how much our life is getting easier. If we were connecting the pins manually, then it was to take a lot of time. 13, this is 14, this is 11, this is 32, this is 12, this is 31, this is 19, this is 20, 21, 22, 27, 28, 29, 30, 8, 9, 10. Okay, that's perfect. Now do for the other side. Again the out net. Now see how much our life has become easy. So we will just be using net instead of using the wires. Now this will be 2. Just connect them first, then we rename them. Okay, just connect them like this. Okay, they are done. Now rename them. This is 26. This is 25. This is 24. This is 23. This is 18. This is 17. Then we have 16. Then we have 15. Then we have 40. Then we have 39. Then we have 38. Then we have 37. Then we have 72. No, it's 36. Then we have 35. A lot of pins, I guess. That is the beauty of PIC16F877A. 34. Then we have 33. Then we have 7654. 7. Then we have 6. Then we have 5. Then we have 4. Then we have 3. Then we have 2. So all the pins have been mapped now. So each pin will go to each connector because we want a connector of female header just like an Arduino. So on the left side 20 pins and on the right side the 20 pins, total of 40 pins. Now what we need is that we need to connect a header like 6-pin header which will be used to connect the PIC3. Now go to the connectors again here. Instead of SIP20 look for SIP6 because PIC requires 6 pins. So that is, here we go. Now apply this filter, click on apply. So he shows you two. This one, they both have the same pitch, so they are the same. Just take one, whichever. Okay, I rotate it. So like this, I place it here. And then after that again, now the beauty is here. Now again, take this net, out net, and you just rotate it. Now I connect 1 here, 2 here, 3 here, for 1 for each pin, 5, 6, like this. Now I connect the pin number 1 to 1 because pin number 1 goes to pin number 1, that is MCLR. Now just make it 1, so it means it will go to the pin number 1. You don't have to make a wire. Pin number 1, pin number 2 is the VCC. So we just connect it, and in our case these two pins, that the VDD and VCC, they must be common. Now instead of like connecting the wire, just make the 32 equal to 11. So now they are shorted automatically. And for the VSS, that is the ground, make 31 equal to 12. So they are shorted automatically. So now net 11 is the VDD and net 12 is the ground. You may write the name as well, like call it V positive and V negative or VSS, whatever you prefer. So here we go. Now this is pin number 11, our VDD. Pin number 2 of the PIC3 is power. Pin number 3 is the ground, just connected. And our ground is 12. Now pin number 4 is the pin number 40 of the PIC16F877A for the PIC3. Pin number 5 is pin number 39. So rename the net to 39 like this. And pin number 6 is pin number 36 like this. Connect the wire. That's all. Now this MCLR wire will also require a 10K resistor. So it needs to be powered up like it is by default in the reset state. So you have to give it 5 volt to bring the microcontroller in the normal state. Now to do that, you just need a resistor. So go to the components again. And now you have to search a resistor. Write down the resistor here to narrow in. Now there are various resistors available here. Through hole resistor is the one we need. Now look for the packages available. Okay, this is the package. This is a through hole package. So what I do is that I just click on place. Okay, there we go. We just place it wherever we prefer. So I place it here. Now again the same beauty will come into play. Make it 10K. You click on it like this, and on the right you have this bar. You click on it, comes out, and there instead of 4.7 we need 10K. Make it 10 like this. And now one side is to go to the pin number 1. You may just connect it or you may use a net, whatever you prefer. For the 2 pin I use a net here. So again we just use this, we copy paste it and connect it here. In this way it's connected. So this is a resistor here. This is for the packet 3, which is now capable. Now we need a crystal because unfortunately PIC16F877A don't have an internal oscillator. So we need to connect an oscillator at pin number 13 and 14. Now to do that, go to the components again. In the component, you write down crystal here to narrow in the search. Crystal oscillators, and here you have various. This is a crystal. Click on it. And now to narrow in the search, you may select the type which you want. Like you want a through hole one or which one. So for that again, you use this bar over here. Look for whatever you are looking for. So there are various type of available like SMD packages or through hole packages, whatever you prefer. So you can see. Okay, we need 20 megahertz. That is a maximum our PIC16F877A can have. And we also need a through hole package. So look for it. Okay, it have SMD. Okay, apply filters, check. CML package, no. CMOS package, apply, no. Not the CMD. Okay, click on crystals. Just you have to search the crystal, the type you need. Okay, they see, yes, this is the one I need. This is the crystal oscillator, but this is SMD one. Why? We do not need the SMD one. This one, yes, here we go. This is the through hole package, that is HC49S. This will do. That is the one I have. So I just place it somewhere here and I make it 20. On the right again, take out this tool, sorry, this one property, and here you have the rating, make it 20 like this. Now it's 20. Now we need to grounding capacitors, 22 picofarad, again go there. Now write down capacitor here. Again you have to do the search because this is a huge library, and that is a good thing. Once you play with it, you will come to know that it's a good thing to have a huge library. Now look for the ceramic capacitors. There are various type of capacitors available. Through hole ceramic capacitor, that is the one I have. Okay, look for the one that you have available. Okay, this will do fine. So what I do is that I need a 22 picofarad, so I just write here 22 picofarad this and apply this filter. Okay, here we go. This is the one I have. I click on place and I place one here like this. Now they are placed one at each pin, or now you just move it so it will automatically connect the wire like this. Now this is a 20 megahertz crystal. Now what happened is that you connect its one pin to the pin number 13. So either you connect it or you just copy this here and connect it here. Press spacebar and also copy the pin number 14 here like this. Now this is the pin number 14, pin number 13, and now from the other end they will go to the ground, and ground is our pin number 12. So pin number 12, one here and one here. That is how much easy it becomes when you use net. See, now this is our crystal connected, one end to the pin number 13, one to the 14, and other side is the ground. So in this way it's connected. Now guys, the next thing is we have our crystal connected. Now guys, our PIC16F877A basic board is ready. Now what I want is that I want to power up the circuit using a terminal T block, a screw type T block terminal. So I go there, I write terminal block, like I want a screw type terminal block, this one, screw terminal block to power up the circuit. So that will be like more easy to connect the wires to power up the circuit. This one will do fine. So I just click on place, I place it here, and our power pin number 11, one is the pin number 12, pin number 12 is the ground, and I call it pin number 1, and pin number 11 is the power. I copy paste it like this. Now they are connected, and I will also need to connect it. Now if you want to add more things, just extend it. Now you have the wire. You may connect the crystal or whatever you prefer. We also connect a capacitor for power rectification. So there are various capacitors available, aluminum or whatever capacitor. So I write capacitor only, capacitor to get a capacitor. So this, and I write the value 22 microfarad or 100 microfarad. Okay, 100 microfarad is fine, and the voltage I want is just 16 like this, I apply the filter. Okay, wait, no data. Okay, no issue. We change the value to okay, apply filter. Okay, we look for the other capacitors, silicon capacitor, aluminum electrolytic, film capacitor, whichever you have available. Okay, this one will also do fine. So we just take a random value, any will do fine, of like above 22 microfarad to 100 or 200, whatever you have. So you just select the package and then we set the value over there. So 47 microfarad is fine. Just you need to connect here. One pin is connected to the power and one pin is connected to the ground. So I just do this to make my life easy. I connect one side to the ground and one to the power like this. Now I also want to connect an LED. So when the circuit is on, the LED shows that it's on. So I write, I just go there and I write LED, press enter. Now it shows options here. So it should be LED drivers, optoelectronics. I guess this will have the LED I want. So LED indicator, okay, just look for the one. So you can see it is showing the LED indicators. So we want the one with like 5 mm. Okay, there are colors, there are angles, there are wavelengths, there are configurations. Okay, there is the power. Okay, then you have the packages. So we'll go down, plug in, SMD. Okay, look for the image that suits your requirement. This one is SMD, SMD, SMD packages. Search the LED. There are like, see, this has huge library, very big. Now this seems to be something like we need a 5 mm crystal type LED. So we look for it. Okay, now to make your life easy, you go to the EasyEDA library. This have less components but useful components. So you go to the optoelectronics, again do the same, look for the LED indicators. Now this is a small library. It is also available in the offline mode as well. Now here again you just use this part, so it will also show us the label that what package means what, because this type of search is not available over there. Now see, it shows us the package, so we will have an idea that what name means which package. So this one is also through. So what is this packet? SOT23. Okay, this is a, okay, this one. Okay, this one is also SMD. I don't want the SMD. Go to the next page. SMD. Okay, this is the through hole TH. No, these are like this one. Okay, this one is the one we need, I guess. So 3D view, click on it. So it looks like this. So this seems to be fine. And what is the dimension? Okay, this seems to be right option. Okay, LED through hole. Okay, I click on place. There, place it wherever you prefer. I place it here. Now to connect this LED, we will also need a resistor like this on this wire like this. Now we also need a resistor. Oh, sorry, we should not place it like this, because if we place it like this, it will get burned. We will need a resistor in between. Now to get a resistor, go back to the components again, and we already have a resistor, this one. So you just copy this resistor, Control C, Control V, place it here, just like this. Connect your LED. One end goes to the power, that is pin number 2, and the other end goes to the LED's anode side, and the cathode side goes to the ground, and ground we have pin number 12. So either you copy the net or you connect it manually, whatever you prefer. I will copy paste the net here. So we got the LED connected as well now. Now guys, we have the LED as well. We have the crystal. Now another thing I want an LCD, LM016 LCD directly over here. Now as we know, I show you. on the browser that how now it is up to you. Whatever the components you want, you may add it into your trainer board over here. Now LM016 looks something like this. So it have pins like this. Okay, where is its pin layout? Let me look for it. Okay, we look for where all the pins are mentioned. Okay, this one. Now take a look here. Take a look here. It has like 16 pins. You can see starting from ground, V, DD, VE and up to 16 pins. Either you look for the LCD or just go and get a, now I show you how I connect it. I go to the LCSC library. Here I write connector again, connector. I press enter, and inside the connector we have various connectors. I write the header only, sorry, header. I write header, and this is the female header that we used previously. And in the female header, I look for the 16 SIP. SIP header is the one I want, and look for SIP 16 because it has 16 pin. Now see, the SIP 16 is not available, but 12 is available. So we use just a 12 one. This one will do fine. I click on place. Okay, 4 and 12. This will be 16. So again, go back to the library. Now you have the 4. Now you apply filter for the 12 one. Here you go, 12. Apply filter. There you go. You go. This is the 12. 4 and 12. They are total of 16 now. Take a look here, like this. You place them together. Now we have 16 pins as per our requirement for the LCD. Like this. Okay, just move this text here if you have any problem. Like this. Now guys, we do the connections again. Pin number 1 of the LCD, just move it somewhere where it is easy to connect. Now these are the optional components. Your PIC will work with this. You have the connectors. You may connect the LCD like in case of Arduino, but I want the LCD to be permanently on the board. So I'm going to use this connector to do that. Now to do that, we have pin number 1. Now on the LCD, if you look at the LCD datasheet, pin layout, you will see that pin number 1. Okay, I save the image so you guys can see it completely. Okay, now ground, VCC, VE and RS. Ground and RW goes to ground. So what you do is that here you have to connect 2 pins, pin number 1 and 5 go common like this, and then they go to the common ground of your circuit. So our ground is net number 12. So this is the ground. I copy paste this here. So here you go, it's now grounded. Now pin number 2 will go to the VDD, but we need a contrast adjusting resistor, a potentiometer. So I go there, I write resistor to narrow in the search, and in the resistors you have various. Now these are the potentiometer, click on it, and now you have various options. So this is the one we want. This is fine. I place it over here, and I also rotate it like this. Okay, this is fine. Now guys, pin number 2 is the VDD. So for the VDD, I bring in pin number 11, this one. This is the pin number 11, this is VDD. Resistors pin number 1 will also go to the VDD like this, and pin number 2 from here also goes to the VDD. So I do this, I connect both at the same time like this. So they are connected, and pin number adjustable pin of your potentiometer goes to pin number 3 of the LCD like this, and then other end of the potentiometer goes to the ground, and that is our pin number 12, and this is the same thing like this. You may not connect the wires, you may connect the nets directly, doesn't matter. And pin number 4, pin number 1 and 5, pin number 4, you go back to the data sheet. Here pin number 1, 2, 3, 4 is the RS, and RS is the pin which will go to the microcontroller. And on the microcontroller, you may select any pin that you want. For this, any digital input output pin will do. I will use a port D. So I use a pin number D0 as the RS pin. So just copy the D0 net like this. Now it's connected. So you don't have to worry about the wiring on the schematic, and on the PCB we will auto route 4. And now for the enable pin, I use a D1. So here look for the D1. This is the D1. So I just copy this net 20. So this is the D1. Now we will be using the LCD in the 4-bit mode. So pin number 7, 8, 9 and 10 are not required. So the next pin that is required is these 4, DB4, DB5, DB6 and DB7. So for the DB7, I will use a pin number D7 of my microcontroller, and DB7 is there, this pin, the third from the right. 1, 2, 3, that's perfect. Now for the DB6, just use the pin number D6, and pin number D6 over here is net 29 there. For the D5, I use the pin number D5, this one, that is pin net 28, like this. And for the 27, that is the D4, I will use the D4, and here D4. Now it is connected. Now these two pins, they are for the LCD backlight. LCD will not have the backlight on in case these two pins are not connected. Now here for the backlight, this is the positive, pin number 15 is the positive, and 16 is the ground. For this, just we need to give 5 volts, so our normal 5 volt supply will do. Now again check before doing it. Okay, this is the ground that goes to pin number 12, and this is the power, pin number second last, this one. So in this way, this is connected now. Now the LCD is connected as well. We have our crystal connected, LCD connected, we have our board female connectors connected, so we can like move on to the next step. Now before you do that, I want also a header, this one, a terminal block header for my UART port as well, because we use UART port a lot. So I add it here just like this, and on the microcontroller I look for the two pins, that is TX and RX. So C6, that is pin number 25, is the TX pin, sorry, and that is 25. I just copy this net, rotate it, I make it 1. If this is the additional header, and this is 26, that is the RX, I make it 2. So if you want any other pin and port of your microcontroller to have a special header like a terminal block type, you may do this at this stage. Now we go to the PCB layout side, and this will auto generate the board layout. So go to the PCB, double click on this, wait. Now you have to go to the top. In this tool section, you have design. In the design, you have this update PCB to schematic, click on it. Okay, that's done. Now again go back to the PCB, and in the PCB you click on place, design, and in the design you have import changes from schematics, bring it. Now the lower one was like if you make the PCB design first, then you may transfer that to the schematic, but in our case we made the schematic first, so these are the components. So just apply changes. So there you go, it brings in all the components over here on the screen. Now see, this is our PIC16F877A, place it here. Just you have to place them wherever you prefer. So this is this side connector. Now see the beauty of it, that we just use the nets and it is automatically aligning it. See how much beautifully it is aligned. So this is our one side connector. I'm just going to connect it right next to it. This is the other side connector. Just bring it near. So rotate it, because I think yes, now that's perfect. Now just connect it wherever you prefer, like this, perfect. Now guys, the next thing is this connector over here is our PIC16F877A. Bring it to the one side where you have the pin number 1 here. I rotate it and bring the pin number 1 here. I will bring it right next to it, like this, over here. Now this is the LCD. I bring it somewhere here. So next thing is our crystal. Bring it in front of the pin number 13 and 14. That is on this side. I rotate it. Now this is automatically aligned. Just keep it near the microcontroller and the grounding capacitors. Just move it right next to the crystal over here. Now see, they are coming in cross, so you just, I think, have to shuffle the places. This comes this side and this comes this side, and it will solve the issue, I guess, like this. Now see, it has become perfect now. Okay, rotate it as well. Okay, now this is perfect. Okay, also rotate this as well. Now this is perfect. Just bring them near, just like this. So these are our crystal. Now see, these are automatically connected. Now if you want to do any connections over here as well, I want to connect these as well. So I just use a tool over here. In the top you see a tool called wire, this one. This is polyline. Now there is a tool called wire here. Via points, this one. Now this is a single routing. Click, go to the wire where you want to add it. I just want to add it, but this have to go to the other layer, so you have to change the layer for that. So no issue, once we are done we will do it. Also it is no longer required, but I will do it. So again, open the tool where it is now, this one. You click on it. Okay, now the layer is changed. Just place 31 to 11. Okay, we will do it on the schematic. So better to go back to the schematic. Another way is to use the schematic if you have the same problem. That was a mistake. So what you have to do is that now take a look here on the connector. We have a problem with the connector. So pin number 32 is not connected. So pin number 32 goes to 11. So you rename this net to 11. So that is the only thing we have to do. Rename it to 11. And pin number VSS is 12 and 31, and also the 31 to 12. So in this way, both sides of connectors are connected. So here we only connected this connector, and there we didn't connected this. So 11 is to 11, 12 is to 12, but while here the 31 and 32 were going empty. So that is the change we need. So now go to your PCB side like this, and at the PCB side you go to the design and you import changes from schematic. Wait. Okay, this apply changes. So now see, it's connected. So you may do it here or you may do it over there, doesn't matter. Now guys, the next thing is we have this switch which is the input for the power. Like this, I rotate it like this. I rotate it like this and place it right, not next to the picket 3, because picket 3 will occupy this space. So we have to move it away from the picket 3 so that it do not get disturbed by the picket. So picket 3 may not get disturbed by this. So we place it here, that's fine. Power in. Now the UART port, this is for the UART connector. So I just move it over here. I have no issue placing it here. And this one is the resistor. Now this resistor is the R1 resistor, and it is for our picket 3 or PIC MCLR pin. You move it here, it's fine like this. Or you may make it like this or whatever is preferred. So I make it like this. Now it's fine. Okay, the LED, I bring it near to the connector. So as soon as the connector is connected, the LED turns on like this. I bring it here. This is the capacitor and this is the LED. I bring it here like at the left side, or I bring it like here, or I may keep it over there as well, doesn't matter. So better thing is to keep it near. The capacitor should be near. So bring the LED over there, over here, I guess. This is the fine place for the LED. Or we may move the capacitor here because it will be shorted in between, and LED over here, and the resistor right next to the LED like this over here. So this seems perfect like this. Now here we go. Now the next thing is the LCD. For the LCD, we have selected port D, and port D mostly lies at this point. So we may rotate it. I will rotate it in this way. So once we plug in the LCD, LCD will be inserted from that side, like it will come from this side. So it will not hurt the PIC. It will be away from the PIC in the opposite direction. So like this, it will do fine. So the LCD is connected now. You may try rotating it, but in this way it will come above the PIC. So this is also fine, this is also fine. So whatever is preferred. So that is how we connect the LCD. Now go to the schematic, look, the LCD wiring is done. Okay, that's fine. Also the wiring for the, go to the PCB layout. Here you go. Now in this way we remove this potentiometer away like this. Now you have to give the board edge. Now to give the board edge, you go there, this is the edge. Now you place the outline for your board, that how big your board is supposed to be. I just start from here and end it here. It says 5170 mil. Okay, I place it right here like this, like this. Now what I do is that I go to the right. In the layers, you have to look for the layer called board outline. You select this. Now this is the board outline layer now. Or go to the right again in the layers. Okay, this is fine. Now guys, what we have to do is that either you may route it manually if you like to. I will do the auto routing. Now to do the auto routing, you go to the left. Here you have the route. Now you have the option of auto routing. You may click on it, click it. Now here you have the options. whatever type of you want, you may set the design rules or whatever you prefer, or you may select components, you may remove the existing speed first, whatever is required. I want the speed first, and I only want the bottom layer, not all layers, to be routed. And here I have the net rules. I have the now you may set the net rule, like how much width of the net you want, like whatever your design rules are, like if you are manufacturing it using your hands, or if you are manufacturing it using an industrial partner, so whatever they prefer, you may set those rules over here. So copper region, whatever single layer pad, whatever the stroke, whatever the length, whatever the track, and other requirements are. So I just confirm it. So to show you how does this work, I click on run. Okay, we are running the auto router. Wait. So auto router has done the routing. See over here, the routing is done. All the wires are connected, no errors. Now see, this wire goes in between it. If you are hand manufacturing it, this will not work. You will not be able to manufacture it. Now if you want to make it like, you want to increase the width of the wires. Now it is also very good board, looking very nice. It can be manufactured. Now go to the 3D view. This is the 3D view. It will also show you the board, how it looks. See, that is how it's gonna look in reality once it's manufactured. See, these will be the female. We only want the through holes, so we will connect the components ourselves. See, they will be the female headers. These will also be the female. Now see how that is how it's gonna look like. Now it looks beautiful. Now I go back to the PCB layout.